I'm Anil Kumar. Welcome to my series on solving previous test papers. Here is a test paper of one of my best students, Suyansh Pandey. Soon he'll be a surgeon. Let me thank all the students for sharing their test papers with me so that I could share the solutions with you, and I hope that benefits in long terms. So I'll actually take up all the questions from this test paper. Let's begin with the very first one here. Other questions will be solved in following videos. Question number 1. Sketch the given function and write its domain and range. F of x is a piecewise function which is equal to x plus 3 for x greater than 0 equals to 2 for x equals to 0 and 1 over x for x less than 0. Part B is write the following. Limit of the function as x approaches 0 from the right side, limit of the function when x approaches 0 from the left side, limit of the function when x approaches 0, then limit of the function when x approaches minus 1 from the right side, left side, and minus 1 as such. Part 7, 8, and 9 are to find the limit of the function when x approaches minus infinity, when x approaches plus infinity, finally the value of the function at minus 2. You can always pause the video, answer this question, and then look into my suggestions. To begin with, let me just make a graph here. So I'm just making a rough sketch. That should help us to get an idea of how to solve such a question. So let me draw some light lines. So in a piecewise function, we have three pieces here. We are working near 0. Okay. I'd like you to pause the video, answer this question, and then check your answers with my solution. That will be good. So this is going to be a rough sketch, but I hope it helps you to understand the concepts. So when x is greater than 0, we have x plus 3. So x plus 3 is a straight line, y-intercept is 3. Now since x is greater than 0, so at 3 we should have a hole, right? So that is what it is. The slope is 1, so that becomes your next point, and we get a straight line in this direction. At x equals to 2, x equals to 0, function is 2. So that is this point, so it is filled in circle. And when less than 0, it is 1 over x. So 1 over x means at 1 it will be at minus 1 it is going to be minus 1, and if it is minus 2 it's going to be half. At half it is going to be 2, right? Minus 2 I mean. So we have these points. Connecting these points we get the graph of our function 1 over x, right? So that is a vertical asymptote for 1 over x, correct? Okay. So that is how we could actually sketch the function f of x. Now, let's try to answer all these questions. The first one relates to the limit when we are approaching 0, the origin, from right side and from the left side. So when you are approaching from the right side, you are in this piece of the curve, right? And so where do you reach? You approach a value which is 0, right? So the value for the first one is equal to 0. Well, I forgot about the domain and range. Let's list the domain and range also. Domain here, as you can see, is all real numbers. How to write the range for this function? That could be challenging. So y belongs to real numbers. For the value of y, we know it is less than 0 on the left side. So we could write that y is less than 0. Y is equal to 2, right? Y equals to 2. And y is greater than 3, right? So, and y is greater than 3. It is not equal to 3, correct? So that is how you could write range of a function which is not a continuous function. Now clearly you can see here that there is a discontinuity at x equals to 0. So let me list that also. So there is a discontinuity at x equals to 0, correct? Now let us answer part B. So limit when x approaches 0 from the right side is 0. From the left side, when we are approaching 0, it approaches negative infinity, right? So it is negatively large value. So we'll write negative infinity here. At times, we may also write does not exist. But negative infinity gives us an idea where the graph moves, so that is a better answer. Part 3 is, what is the limit of the function at x equals to 0? Now, since left side limit is not equal to right side limit, it does not exist. The reason is that the left side limit is not equal to right side limit. Perfect. So that is how we could answer the first 3. Now let's look into part 4. We will now try to understand the limits at -1. So we are concentrating now at -1. So when you approach from left side and right side, you are approaching a value which is -1. Clear? Therefore, the limit from both sides is equal to -1. Correct? Since both the limits are same and it is continuous at this point, we know this limit is -1. Clear? 7. What is the limit of the function as x approaches negative infinity? Now, when x approaches negative infinity, what we see here is that the function approaches 0, right? So the limit of the function as x approaches negative infinity is 0, right? So that is what we'll write here. So this is 0. When we are approaching positive infinity, it is positive infinity, right? Or you can say does not exist. So both could be the right answers. It's good to write positive infinity since we see the end behavior. So these two limits also give us end behavior of the function. At times, we also write this as 0 minus, saying that it is approaching 0 from the negative side. F of -2 is what? Value the function at -2. So at -2, the value of the function is -half. Perfect. So that is how you're going to solve this particular question. Now here we learned a lot of things about piecewise functions. One, how to sketch, how to identify the points where the function is discontinuous. Right? So from the limit also, if the limit does not exist, then the function could be discontinuous, as we have seen here, right? So in this particular case, we have a jump discontinuity at this point, and it is therefore not continuous. The value of the function at 0 is 2. It is not the same as the limit approaching from left or right. Perfect. Now that is very important to understand. Well, we saw that at -1, limit exists, the value of the function is same as the limit, and the function is continuous at that point. Correct? And when we talk about limits at positive and negative infinity, we are looking into end behavior. So I hope that gives you good introduction to calculus. Now, in the following videos, we'll take up other questions related to limits.